Hi, I'm Esther.
And I'm Sean.
I write about AI news here at Tech Target.
And I edit Esther's stories.
We're here to talk to tech experts about everything AI, from open and closed models to AI agents and who's ahead in the generative AI race.
And even the elusive AGI.
We've got it covered, right, Sean?
Yep, we've got it covered. Hi, everyone, and welcome to another episode of the Targeting AI podcast from Tech Target Editorial. Our guest today is Greg Pavlik of Oracle. He's Executive Vice President, AI and Data Management Services for Oracle Cloud Infrastructure. Greg's responsible for strategy, service definition, applied science, and delivery across Oracle's cloud portfolio with a focus on AI for enterprises, if I'm correct about that. This is Greg's second stint at Oracle. Before this, Greg was Chief Product Officer for Hortonworks, a former big data software company that had an open source approach based on the Apache license. And at Hortonworks, he helped create the on-premises big data business back in the early stages. So thanks for being with us today, Greg.
Oh, thank you for having me.
So we're going to start with Cohere, maybe the most recent chapter in your AI journey. So how has Oracle's relationship with Cohere, for everybody that they're the independent generative AI vendor, how has that relationship evolved since Oracle invested in Cohere as part of a $270 million funding round in June 2023? I have to ask you, how much was Oracle's contribution? You may not want to say, but I hope you do. And whether does Oracle plan to invest more in Cohere?
Yeah, so I can't comment on any non-public financials, but I can comment on the relationship. So, we have made a decision to really partner deeply around the foundation models. And what we're looking for are companies that are experienced with creating high quality generative AI models, number one, but as importantly, I should say, companies are interested in enterprise and specifically business solutions. Because if you stop and think about where did these things all come from? Research communities in academia, search focused companies, social media focused companies, all good stuff, and all resulting in powerful advances in the field. But the problems that they're trying to address and the patterns that they're going after are not the same problems and patterns that you see in sort of typical business applications or solutions and workflows. And we realized this kind of early on when we started to look at these partnerships. We were taking models and we were applying them in the context of our SaaS portfolio, in the middle of workflows for human capital management, for supply chain management, ERP and financials. We're using the models and realizing that, they were trained for other things. And so the advantage really of having a deep partnership is that we're able to sit down with the foundation model providers and look at the evolution of the models themselves, because they're not really static, right? A company will create a model and then they'll continually retrain it. They'll create new versions and updates. And as they're evolving the models based on whatever requirements are being fed into them from their own core businesses, we kind of see our role to come in and proxy for the enterprise user, proxy for a number of verticals, and then try to move the state of the art in the technology base closer and closer to the kinds of patterns and the kinds of scenarios that are important for enterprise users. And that's been very successful for us. I mean, when we started, we found gaps, we found holes, we found patterns with the first generation Cohere models. We worked with them on the data sets they were applying during training. We worked them on the preference tuning, instruction tuning, even in pre-training data. And we've been able to make the models just better for businesses. And we'll say one thing. One of the reasons we really like the idea of open models in the ecosystem is it also gives us more access to start to look at how we push the evolution of the models, again, in the direction of what will work well for enterprise scenarios, what will work well in a vertical context.
Thanks for that, because our audience is enterprise users, so that's awesome.
Yeah.
Yeah,
Well, that is the key challenge, right? Like there may be, say, a dozen different quality large language models in existence right now, but very few of them have really taken enterprise as the core focus. And there's just, there's domain understanding, there's very specific requirements in terms of formatting and outputs, prompt understanding. I mean, there's just, you go through layers of challenges. And so having the ability to like really lean in and force the evolution of the model in the direction that matters for our business and for our customers' business is actually the key problem today. And we've also, one other point I'll make, we've stopped looking at the models as kind of point in time snapshots, and we really do think of them more like evolutionary organisms. That they're all benchmarking and doing well on benchmarks and kind of leapfrogging each other, and that's all good. That's all important elements of progress in the field. We have come to the understanding that really these are things that are going to continually evolve. And one of our main functions, one of our main value adds, honestly, in the market is to help the evolution in the direction that makes it useful for businesses.
That's very interesting. I wonder then, what would you think has been the evolution from the popularization of ChatGPT till now? How do you think the different models in the market have like grown or shifted, and do you think they've shifted in the right direction?
That's a great question. It's clear that the quality of the models has improved and continues to improve. So just their ability to have a better understanding of prompts, do better instruction following, the behavior around summarization, or even control of output length based on instructions. These are all things that the models have gotten better at. If you look at the public benchmarks, you can see that the models are continuing. It's almost like an evolutionary arms race. They're continuing to make progress. One thing that is clearly true is that we have more powerful models today than we did a year ago. One thing that's not always noted, but I actually think in some ways is as important, is that the models are not only getting to be more powerful, but they're getting to be more efficient. Right, so we've had the emergence of maybe mid-sized models that are able to execute on par or close to on par with the frontier models, but they're orders of magnitude smaller. And the significance of that, it's hard to underemphasize the challenge that is faced today generally for businesses, right? Which one is the model good enough, right? Is it able to do the kind of workloads I need, right? And that's improving, so that's good. But the second big challenge is how much am I going to spend to run these things? And a lot of times, with GPT-4, for example, companies would go and they'll do a bunch of prototypes, they'll get good results, and then they'll get their bill. Right? And then it's like, oh my God, so let's retrench to something else. The emergence of a newer generation of more efficient models is been really important trend in the market. So for example, with Cohere, their Command R model is a 35 billion parameter model. With fine tuning, it can often get, proximity to GPT-4 performance on a number of use cases, but as significantly, we can run it in a single GPU. So the economics of serving the model for inferencing are also orders of magnitude cheaper than what we were seeing, just 2 quarters ago, 3 quarters ago, for models of the same quality. So this price performance trade-off, or this price performance ratio, is I think one of the things that's driving end customer adoption. And on both dimensions, we're seeing big improvements happening, very rapidly.
One more question, Uncle Er. I wanted to just say, like, what do you think? I guess, what is the benefit of Oracle and its customers of using generative AI technology from a third-party vendor rather than perhaps developing it itself? And what percentage of Oracle's large language models and AI agents, including those in OCI, are based in Encore's technology?
Okay, gotcha. I think the advantage for us in terms of partnership is that we were able to get into the game immediately with high quality models, right? Because to build these things from scratch and build out a team, it just takes time, right? It's time and expense. So from just a pragmatic perspective, coming in and working with companies that have world-class science teams, already have at least one or two generations of base models built out. It just gives us a quick on ramp to be able to really get into building high quality solutions. And if for Oracle, when it comes to actually delivering generative AI capabilities, there's two dimensions that are important for us. So one is at the level of platform services. So if you come into OCI, you can come in to use the OCI generative AI service. You can use our agentic platform, and you get these capabilities kind of out of the box, curated, turnkey. It's easy to get going. We also deliver generative AI across the application, our SaaS application portfolio. And if you look at the SaaS portfolio overall, Fusion Apps, NetSuite, there's about 22 different vertical businesses that we have applications for. If you, in the aggregate, we've got the largest SaaS portfolio on the planet. So all those apps are plumbing in generative AI capabilities into their core workloads, and they're all building on top of the same generative AI services we offer to our customers in OCI. What's interesting about that is, of course, it helps us, all that pressure to make the services more efficient. But it also goes back to the earlier point I made, which is where we can work with the vendors and improve the models based on the workloads we're seeing in apps. In many cases, those are the same kind of workloads customers have in their, in their own bespoke applications, in their own business workflows that are running completely independent of the application, the SaaS applications. So you kind of get this double benefit where we can give people high quality generative AI driven solutions that are more or less turnkey, right? And they can accelerate and get efficiencies in workflows and applications they're already using now. At the same time, we can make the models better, and then we can make the models available with those improvements to our customers so that they can apply generative AI, wherever they need to in the broader enterprise context. So it's worked out well from that perspective. Percentage of I should mention, if you go into the OCI generative AI service, we have Cohere models. We also have meta models. We've kind of taken an approach where we're not trying to give a model garden with everything under the sun. We have different mechanisms you can use to deploy any model you want easily. But in the truly managed environment, we really have tried to narrow the aperture or the lens on the market space and put models in there that we have a high degree of confidence will work well in the enterprise scenarios, and where we have a relationship with the company that's providing the models so that we can continue to make them better over time, as we put all this pressure on it from within the SaaS world or within our customer applications.
Do you have like a gauge? Like, how would someone know, or an enterprise know, it's better for me to use Core, or it's better for me to use Meta? Like, how do they determine that? Or is it just a preference of like, just use whatever you want and figure it out?
It's a hard question actually to answer. The reality is the public benchmarks are useful for comparing models in terms of their progress on specific dimensions the benchmarks look at, but they're rarely indicative of how they'll perform in production scenarios. So we have our own evaluation toolkit and suite that we use internally that we kind of try to make judgments across the models in the market and how well they perform when we really try to put them in through production workloads. But I think customers often struggle with this. And one of the problems I see right now is we've got a set of customers we'll go talk to, and they're taking a dozen models and they're constantly putting them through tests and benchmarks, and they're spending a lot of money doing it, but they're not coming around with like any final decisions like, okay, we're going to bet on this model line and we're going to take it into production and actually drive value for the business. So we've been trying to steer away from that and, like I say, limit the I don't want to say limit the options, but really provide curated experiences that we think are being tuned for these kinds of scenarios that most businesses are looking at. And then we will work with the customers individually too if there's open questions about well, hey, do we want to go with Cohere R Plus versus Llama 405B? There's trade-offs with that. And we'll give them our experiences and also, work through them on kind of what's, the cost factors involved with those as well.
Okay, so you guys are not all in on generative AI, but definitely a major piece now with Cohere. But before generative AI really emerged in a big way for enterprises and consumers a few years ago, I mean, you still were working with AI. We call it now traditional AI, right? And so,
Yeah.
how did your strategy evolve from that old school way, that AI, predictive or analytical, whatever, and machine learning, into generative AI? And how did you decide when to get into generative AI? And did you just like jump into it, or had you been thinking about it already?
Yeah, we've been making the investment we've had from Oracle Cloud perspective on the machine learning front goes back a long way, and then Oracle, even within the context of the database, it's literally decades long investment on the ML side of the equation. One of the things that we created out of that was kind of a common infrastructure that we run all of our businesses on for serving machine learning algorithms, either directly into a customer application or within our own application portfolio, within our own SaaS portfolio. So we wound up with a lot of experience in understanding how to integrate, productionize, and maintain models over time in real world applications. When generative AI came along, we used the same machinery and the same infrastructure to do the hosting on the models. So that actually wound up being fairly straightforward. The big change for us around generative AI was actually less on the inferencing and using it in the applications, and it was more at the base infrastructure level, or IaaS business. We had developed a technology for ultra low latency networking across a large number of GPUs. Came out of our early investments on clustered databases, and then we evolved it and applied it in the HPC space. And when generative AI started to become a real thing in the market, we really went into that full stop. We went after the generative AI training side of the equation with what we call the OCI supercluster. And those have become, they become an enormous business for us, but in many ways they become, the preferential platform for generative AI training in the industry. And, customers, they run the gamut from XAI, NVIDIA, OpenAI, through I think about 40 the private equity-backed startups. So I'd say the biggest inflection point for us was really scaling the supercluster technology and getting that into a position to really provide the market with the best price performance environment for doing training of these models. Now that also had another benefit, which is when these generative AI companies become customers of ours and they're training on our platform, it's often easier for us also to work with them collaboratively on the progression of the models. So, for example, Cohere is also a customer on OCI, and so when we look at how do we evolve the models, how do we shape the training of the models, how do we engage from a preference tuning perspective to improve the behavior of the models, it tends to be easier as far as a working relationship goes if they're also running on OCI like we are.
Interesting. What would you say is Oracle's approach with like AI agents? What do you guys consider AI agents, and how do you do your data? Like, how do you make sure that your data is secure?
Okay. The agent uh, situation is pretty interesting, right? So I think the topic of the day is the most popular thing everyone wants to talk about is generative AI agents. And if you look at the way, and again, you don't have to go back very far, go back 9 months, right? The agentic models were really based on this approach called React, which was assume that the models would apply reasoning to generate a plan, and then they'd be reflective about the execution of the plan as you move through the interaction with the user. There's some amazing POCs for agents where you can set them up with tools, ask them to do tasks. They'll find information. They'll use that information in combination with your instructions, and they'll go book trips or hire people and so forth. The difficulty is it actually turns out that the large language models reasoning capabilities are not reliable. And so you get some great POCs, but then you would also get these agents that were successful, 60, 70% of the time or something like that. Whereas, if it's a mission critical workload, you need to be successful all the time, right? So that gap turned out to be enormous. We sort of stepped back and looked at it, and we had done a lot of early research work on applying the React pattern and agentic development. But the conclusion we came to is rather than give people a kind of a toolkit that was built of parts that when you put them together would never work reliably, we really went after it from a different perspective, which was to build agents for specific tasks where we could control and put guardrails in place so we knew they worked reliably. So, for example, maybe last quarter, we released our retrieval augmented generation agent, which allows you to do kind of a turnkey configuration of the agent system so that you can point it at a database or point it at a open search cluster and just talk to your data, right? We're doing some similar things with natural language SQL. We have a thing called Code Assist, which is really around developer productivity. We're working with our application teams to plug in agents within the context of the apps. Again, where we've got targeted scenarios, we know they're high value, we know will work reliably, and we can provide to our end users so they can have these kind of multi-turn conversations to accomplish tasks or get access to information successfully, but without going off the guardrails. With these end-to-end scenarios where the models just aren't currently at the level of reasoning and planning where we can put them in production for arbitrary scenarios successfully. Now, the models I expect over time and the science will adapt and change, and of course we'll make adjustments with that, and we'll open things up so that people can build on our own agentic framework as well. Same technology we use to deliver these turnkey, more solution-oriented agents. But we don't want to get ahead of the curve when it comes to the enterprise users, because once you put something out there where people play with it, they like it, but they can't really get it to work, you lose a lot of credibility and a lot of traction. And we want to build on the momentum we're seeing with the adoption around generative AI and keep people getting the successful outcomes and really high return on investment.
To hear the full audio podcast, please go to Apple Podcasts, Spotify, Amazon, Audible, TuneIn, Podbean, and other popular podcast platforms.